Okay, welcome everyone to this continuation of what is machine learning in mathematics, right? Machine learning in mathematics, already part 11, and finally I think I should, talk about the elephant in the room, the key question, how to ask questions. So the key question is how to ask questions. Essentially, AI is not really good at giving you ideas what to do research on, right? That would be amazing. So let's try that actually. Let's see what comes out. So I just open some usual AI thing and I ask, I never tried this before. We'll see what happens. I'm a mathematician. I don't need to learn spelling and need a research problem. Make a suggestion. Now I'm curious what will happen. Great! Since you are, I can tailor. Oh, wonderful. Blah blah blah. Problem suggestion for general algebra and number theory. Exploring the interpolation between torsion points of abelian varieties and unlikely intersection theories. Yeah, that's not a good idea to get that started. That's very difficult. So let's say I'm doing graph theory. I work in graph theory. Let's just say that. And we'll see what happens. Yep, perfect. Graph theory is such a fertile area. Wonderful. Research problem. Structural characterization and external bounds for graphs with constraints locally expanding of global sparsity. Problem statement. What I'm supposed to do? Good question. So anyway, I'm pretty sure remedy theory and extreme combinatorics. Possible research question. Can we classify hereditary classes with dense local structure but globally bounded tree width? The problem is, it's so much waffle, I actually can't tell whether that's actually really a honest research question. But I doubt it, and the whole point is, I think AI is very far away from, oh, you can try that yourself. Let me know if ChatGPT actually, or any AI you want to use, actually can recommend a good research question. I kind of feel like no, right? So that's kind of the whole problem with AI. Everything I showed you so far had still a lot of human input. So kind of how to ask good questions is one of the key open problems, not just in AI and mathematics, but literally in AI in general. So, question versus answers. So I still think that mathematics is mostly about asking good questions. Maybe it's even the art of asking good questions. People might disagree with that, but I feel like asking the correct question, it gets you very far in mathematics. And somehow questions are sometimes more important than answers. So yeah, like 42 is the answer to the ultimate question of life, but we forgot the question. So somehow the question was way more important probably than the answers. And the whole goal in the end, at least in my personal point of view, again, my humble opinion, should be that AI should ask meaningful questions. And I guess as soon as that's possible, I'm not sure when this will be possible, I'm not sure if that will be possible, but I'm pretty sure that it will be possible eventually. Just keep in mind that AI, like, from the 1950s roughly, so whatever, 70 years plus in development, the human brain had a little bit of a head start here. Anyway, so it might take a long time until this happens, that AI asks meaningful questions. But if it can really do it, then we have achieved our final goal to get rid of all human involvement in mathematics. But as far as I can tell, we are very, very far away from that, actually. So AI is very useful, hopefully, if you jump into video 11 and you haven't seen any of the others, I would recommend to, at least take a look at the others. I'm kind of referring back to them right now. So this video is not, in that sense, not self-contained. So what we have seen so far is mostly type of kind of a thing where AI was used to kind of guess a pattern, but you wanted to see that pattern anyway as a human, and you just used it kind of and then decided later whether it's interesting or not. Also, the literature is very biased on that. So if you use AI to guess pattern and write a paper about it, then there's this implicit step involved where, since you write the paper, you think it's interesting. I have done a lot of research in this area as well, but most of it is not published. Why? Because turns out that AI discovers a lot of bullshit that you don't care about, right? So that's the whole problem. And again, the literature will be biased because things that human likes will get published. So what I really need, not just what we really need is AI to ask meaningful questions, right? So really kind of whatever, sort out the zoo of possible research questions. And the whole point, I think, to summarize, kind of oversimplify it, is a bottom-up and top-down. So I ask AI, and then I was pretty good in recalling the literature, what is the most famous math paper? And it came up with something like Euclid's Elements. I guess that's not really a paper, but at least that's very popular. And Euclid's Elements is a good example of how math literature actually is written. Although it's like not the newest book in the world anymore. But anyway, it's all of math literature, or most of math literature, and also mostly how math is taught is what I would call bottom up. Yeah? So bottom up literally just means, let's see actually what it is. Bottom up, top down. I guess these are the two differences. Bottom up, top down. Something like... something like that. So what is the best one? Bottom up. So top down. Ooh, let's open that. I like that. So here's a block. So the idea of bottom up and top down is doesn't just appear in mathematics. There's management style here in this example, or wherever. So very nice block here. So here, whatever. And there was one picture that I liked that explains that very well. Blah 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 blah. Maybe this one here. So top down is something like you encourage people, and and one of them is you encourage people. The other one is you lead them. It's kind of different types of management style, and usually both of them are useful. Huh? And there are various different things you can, as I said, top up, bottom down. Top up, bottom down. That's not a good idea. Top down, bottom up these are like classical questions, classical ideas in how to organize something, not just management, but also mathematics. Turns out that math literature is mostly bottom up. By that I mean, you usually build foundations, right? You usually first learn what whatever is, and then you learn what whatever is, and then you learn what whatever is, and it kind of builds all on one another. While research itself is kind of the other way around. Essentially, no one I know does research bottom up. So you don't write a paper about here's an abstract concept. I have no idea where that comes from. I just write it down, and then I build on top of that abstract concept. I build on top of that abstract concept, and so on. Mostly it's the other way around. You get your hands dirty. You find a pattern you like, and then you build a theory that kind of fits to the pattern. Right? Math research is top down. You first play around, then you build the theory, while how it's taught and how it's written in books and papers, Euclid is a good example actually, is bottom up. Yeah, so you build everything to go upwards. But this is kind of backwards, in the sense that if you build something bottom up in mathematics, you actually know where to go, right? And this is like kind of one of the big problems in how math is taught, that everything is taught bottom up. And then you eventually expect students to do the top-down approach, and very often they can't do it. And who can blame them? They've always learned to go bottom up, and it's like very difficult to see how anyone would ever come up with that theory, because you learn it in the wrong way around, right? You learn it in the historically wrong order. That was a long waffle and actually completely off topic. Not quite. So the point is, AI is great for bottom up. It's like one of the key advances that we have seen in the previous years, 10 years, if you watch this in 25, so like from 2015 onward roughly, is AI is absolutely fantastic for bottom-up mathematics, like formalization of proofs. Absolutely fantastic. For top-down, so kind of the whole point of this video is like this top-down thing. How can I find good research questions? As far as I know, it's not really that great, right? So it's kind of very good for the bottom-up thing. Formalization, checking axioms, something like that. It's really good for that. Top-down, we can't really do that. Yeah, so standard thing. So the automated conjecturing, which I have like made so many videos about, is one of my favorite topics. Automated conjecturing. Yeah? Automated conjecturing, no human. So the machine should make its own conjecture. And if you read what the automated conjecturing does, usually as output, is it's more like this kind of big approach where you just list all possibilities. Yeah? You list all possible conjectures, you get whatever, a million conjectures, and like everything except one of them is completely boring. Yeah? So most conjectures in this way are completely boring, and we don't know any way how to fix this as far as I know. So what would be really good is kind of to not just generate a list of possible conjectures, but also to have AI to decide which one is interesting, right? So it's like, you have a list of possible conjectures, what on earth are you going to do with that? So there will be some human who tries to read it, way too much work. There should be an AI that just reads the conjectures and says, oh, this one, by the way, looks really good. We should try to do that. But as far as I know, we can't. And then I was trying to prepare this video, and I was looking for, well, what has been done. And I decided to go for this paper, which is by now not the newest anymore, 2018. Again, we're in 2025 while I'm recording this video. So essentially is the question I'm addressing, right? Can machine learning identify? The way, the approach they take in this paper, which is like very hands-on, and again, AI is not going to do a good job in this direction. So it's kind of the easiest first thing you can do is they take kind of, I think we'll see it in a second, 40,000 examples of sequences, integer sequences from my favorite website, the OEIS. So there's this really good website where you can just input an integer sequence, do a search, and whatever. Result found, numbers of trees with n-labeled nodes, whatever. Yeah, and the question is, can we somehow identify what sequences are interesting, right? So is there some way that the AI can decide? You give them the sequences, there's easy accessible data, you can download whatever, how many entries, 300,000 entries, or God knows how many entries this integer sequences thing has, and it has some labels down here, some keywords. So everything is labeled, and you can ask the question whether I can train AI just on the sequence, and it kind of tries to identify the labels, which is like very far away from the original question we had in mind. But there's something like easy, nice, whatever, you know. So can AI just learn from the sequence what type of labels human gives the sequence? Yeah, that's a very, very baby step towards the idea. Can AI actually generate good questions? Here in this case, can it identify what human likes in terms of sequences? Is there a bias? It's a pretty cool idea. Is there a bias on an integer sequence? And yeah, they studied this in this paper. Just really nice, and well, they got some very, very nice results. We'll see in a second. So they trained a neural network. Oh, I should go on with my slides, I guess. So they trained a neural network, and it did not too bad actually. So roughly 50%. And we can have a look at the paper. So they trained a neural network. They had a baseline. There's a neural network, and they compare whatever accuracy, precision. There's various different ways to compare the output. Let's just say with accuracy, and it goes roughly up to 50%. They also did something slightly different, and you can somehow order them. They also ordered that by different various whatever the labels. Here's our neural network. Can it identify nice? Can it identify prime? Whatever. These were the labels. Easy. These were the labels for the sequences. And I think this is kind of a cool question. And the neural network was doing not great, reasonably well. It was kind of a plain neural network in 2018. Probably we can, at this point, just improve that. But it's kind of a very, very baby step in that direction. Right? It's kind of a really great idea, but like a tiny step in that direction. So here's a research question, in case you care. So they also did something different. Oh, by the way, they had 40,000 sequences studied. They essentially observed, so sequences in the OEIS are not really random. It's something people like and put online on that site, right? They're not really random. And it turns out that there's some form of a bias in those sequences. And I don't know where it comes from. And also the paper doesn't know where it comes from. It's an interesting open question. Turns out that there is kind of a very strange relationship. So they said most of them satisfy Benford's law or Taylor's law, certain types of laws in, well, statistics, essentially here. Taylor's law, for example, the mean and the variance in real-world data is supposed to satisfy a power law, and essentially there's also a bias in the OEIS, similarly for Benford's law. So strangely enough, sequences in the OEIS kind of have a human-made bias somewhere built in. It kind of would be interesting to study that. But that's not directly related to the original question. It was just something I found very exciting, and I wanted to end with a potential research question. So is there a human-made bias in the whatever, how many hundreds of thousands, tens of thousands? I have no idea how many sequences there are on OEIS. So is there a human-made bias? But anyway, the neural network did reasonably well identifying the labels human gives to sequences, right? So it's really the question, what do human like about whatever type of integers sequences, the odd numbers, type of integer sequences. Anyway, I hope you enjoyed this video, and I also hope to see you next time.